So our next chapter, we're going to be dealing with several different things. The first notes here, we're going to be dealing with lines and what's called transversals. We'll talk a little bit about parallel lines in this one, but that's going to be more the next lesson. As the top, it says you need 3 color pencils or to color code the notes. Please go ahead and pause, grab 3 markers or 3 crayons, 3 color pencils, 3 colored pens. We're going to need this for a few different things today. So the first thing, let's go ahead and define these parallel lines. We should already know one thing about parallel lines, but what else we need to know is we use these terms planar and coplanar and non-coplanar in a previous unit. Parallel lines are going to be coplanar, so they're going to be on the exact same plane. They're going to be coplanar lines that never intersect. The never intersecting should be something we already know about our parallel lines. So in our diagram over here, we're seeing that example line, there's our line symbol, line JK is parallel to line LM. Your parallel symbol can look one of 2 ways. It's either just going to be 2 lines straight down, or you might see it, I'm going to erase this, but you might also see it diagonally like this. But it's a representation of 2 parallel lines. Okay? A real-world example. Think about some real-world example of 2 lines that never intersect. Well, think about railroad tracks. Railroad tracks are not going, now we're talking about the 2 sides that the wheels go on. They're never going to intersect. You've also got lines on the road. Again, looking at, 2 white lines that you follow between. Now we have what's called skew lines. Skew lines are going to be non-coplanar. So we will be entering a 3rd dimension here, okay? These lines are also going to never intersect. And then we have these examples right here. We have 2 completely different planes, okay? We've got line L right here and line M. Because they fall on 2 different planes, and the planes are not going to intersect, these lines will not intersect. I've got an example here, a real world example. This might be a little harder to come up with on your own. Let's take Highway 90. Okay, Highway 90 is going to be the main road through Old Town Katy. Okay, even if we take a straight stretch of that, and then we take a look at the flagpole, the Katy High School flagpole, that flagpole is not on the road. It's to the side of the road, and the road is going to be horizontal while the flagpole is vertical, and that flagpole does not go into Highway 90. So we can write flagpole at KHS. These are harder to come up with. Don't focus too much on, oh my gosh, I got to come up with a real world example of skew. No, you're good. Now we're going to talk about parallel planes. Parallel planes are they're planes that never intersect, that parallel part of it. Okay, parallel means never intersect. So again, looking at this same example here, plane A and plane B are not going to intersect. There's not really a symbol there to show like we have with our parallel lines. We have these triangles, or we'll have little carrots. We'll see both examples. So here we've got these 2 are parallel. Some real world examples, all right? I asked my students in the class while I was looking at this, just, hey, what do you think? And I was given, okay, look at your classroom, or any room, technically almost any room, you've got the floor with the ceiling. I think it's I before E. Nope, we got E-I-L-I-N-G, I think. That's why I teach math. So your floor and the ceiling, okay, in any regular room, if the floor is horizontal and the ceiling is horizontal, they will never intersect, but now we're looking at 2-dimensional. So we're going to go ahead and we're going to take these diagrams here, and we're going to use our colors and identify different skews, parallels, things of this nature. So we're going to have our 3 colors. We're going to list all segments that are parallel to segment JP. So we need to find segment JP. It's going to be this piece of the cheese right here. So we're going to take one of our colors, JP. So we want segments that are parallel. So we're looking at this cheese. We've got a lot of different segments going around here. We need to find the ones that will never intersect with segment JP. Here, back here, we've got segment KQ. And over here we have segment LR. And that's it for this one, okay? The KL, you might look, okay, well, those are never going to intersect, but they are not on the same plane. All three of these segments are all three going to be that vertical on the same plane. Now, if we take a look at the next one, we want a segment skew to segment JL. So let's look at segment JL right here. We want to get a segment that is skewed. So we're looking for a segment that is not on the same plane and that will also never intersect. I'll go ahead and help you out. The skew line's a little bit more difficult to see. Look back here at segment KQ. Okay, now when we draw the two-dimensional, it looks like they intersect, but if you take that third dimension, these will not intersect. JL will keep going this way. KQ is further back in this third dimension, and it's not on the same plane. It's going to go the opposite direction. Now we want a plane parallel to plane PQR. So first, when you remember a plane, 3 letters, let's find those points, P, Q, and R. So we're looking at this little triangle of the cheese. There is only one plane in this example that is parallel, and that's going to be the top triangle cheese right here. So we will call this plane, and it only has 3 points, JKL. And you can rearrange those 3 letters. Now taking a look at this cube over here, we're going to identify some more. Let's first look at all segments skew to segment BC. So let's find segment BC. Now we don't want any parallels, so that rules out AD, FE, GH. Okay? We also don't want them intersecting, so we can't choose CH because that's going to intersect. We can't choose BG because that's going to intersect. So here we could take a look at, well, what about down here? EH. EH is never going to intersect, okay, because that one's going to go further back. So we can write in segment EH. Look over here also, FG. Anything parallel to a skew line is going to be skew as well. So FG, segment FG, apologize. Also look right here, we have AF. Now AF will intersect with FG, but again, we're just looking at here at BC. This will never intersect either. And then we find another one here, DE. I did misspeak earlier. Just because they're parallel does not mean they're going to be skew. I apologize. But here, AF and DE, these will never intersect BC either. What was that, DE? So now we're going to look at a segment parallel to segment EH. So let's go find EH right here. We want to, okay, we just want one. Okay, there will be several, but here we're looking at EH. We can call out right here segment CD. I also want you to notice that segment FG and segment AB will all be parallel to segment EH. All planes parallel to plane DCH. So find D, C, and H. So we're looking for all planes that are parallel. There is only one, and it's going to be this plane over here. So now that we have 4 points on this plane, the 4 vertices, remember that a plane is labeled with only 3 points. So between A, B, G, and F, any 3 of those, any combination of 3 of those will work. I'll just say A, B, and G. So let's go ahead and continue on, and let's talk about what a transversal is. Okay, what is a transversal? It is going to be a line that intersects 2 or more lines at different points. So these examples down here, they show a transversal. We're going to go ahead and draw it in now. I'm going to draw 2 lines that are obviously not parallel because the parallel is going to come in later. Just like these diagrams down here, you can tell they're not going to be parallel. So we have these 2 lines. We're going to draw the transversal. It is going to intersect both lines at different points. Okay, and it doesn't have to go this way. It can go diagonally the other direction. It can be anywhere on this line. But this guy right here that cuts through 2 or more lines at different points, that is going to be your transversal. So when we're talking about the transversals, to set up the basis before we move on to parallel in the next unit, we need to understand the relationship with the angles. We're going to have several different kinds of angles that are formed. We've already talked about linear pairs, which are going to be on a line next to each other, which we have several, okay? Several different linear pairs. Those only occur at the intersection of 2 lines. Vertical angles across the vertex here. Let me get something to point with. Vertical angles across the vertex. Here's a pair. Here's a pair. Again, only happen with the intersection of 2 lines. Once we bring in this transversal cutting through 2 or more lines, we're going to have 7 more different kinds of angle pairs that are going to arrive. So first focusing on the transversal, okay, or sorry, no, actually the lines L and M, the 2 lines that are being cut. Your angles are either going to be formed on the interior of these 2 lines, or they're going to be formed on the exterior. We're looking at, okay, in the road and out of the road, okay? I don't know other teachers that do this, but if you look at line L and M, I know they're not parallel. We're going to say that the lines in the road are not parallel. But if we're looking at, we've got this little car, here comes my great artwork, driving down the road, we're looking at angles that are on the interior in the road, and they're risking getting hit by that car. Okay, so we have, here's the interior between the 2 lines. And then we have our exterior that are going to be safe from harm's way as long as the car doesn't drive off the road. We are exterior outside of that road. So there's one thing we have to look at. Both these sections are going to show us the 2 different names, or the 2 words that go into the names. So we have either interior or exterior, so that's one way we focus. And then they're also either going to be located on the same or alternate sides of the transversal. So we take a look, now we're looking at the transversal, not the lines that are being cut by the transversal, but the actual transversal. I don't have a way of writing it to really make it cleanly show the alternate. Alternate is just going to mean opposite sides of the transversal. But with your same side of the transversal, when we're looking at the same side, if we rotate this page, we can write over here, same side, showing that if they're both, in this case, to the left or to the right, then they will be same side. Alternate would be 1 to one side, 1 to the other side. So let's go ahead and take a look at what kind of angles we have using this diagram. Zoom out so we can see the whole chart and the diagram. We're going to first take a look at what's called the alternate interior angles. So your names, alternate and interior, are going to come from this top part. We're going to want alternate opposite sides of the transversal, interior inside the road. So again, here's your opposite sides, that's your alternate, right up here, meaning the alternate road, side of the transversal, and they're going to be between the 2 lines. That is our interior. So we take a look at the diagram up here, we want to list all examples of alternate interior angles. So let's go ahead and take a look. We are looking at inside the road, so if you want to draw your little car, sometimes they start looking like UFOs with me. Interior, so we are taking, that's why I like the document camera, inside the road. So all of our interior angles are going to be 2, 6, 3, and 7. Now that we're interior, we need to identify alternate interior. So let's take a look at angle 2. Angle 2 will be an alternate interior. So alternate, we need to go to the opposite alternate side. Now, not 6. 6 is a linear pair. So we need to go to the opposite side over here to the opposite side of the road to alternate interior. We have to cross that transversal while we're crossing the road. So angle 2 and angle 7 will be alternate interior angles. Then we take a look, we have another pair. We have 6 and 3. 6 and 3 are inside the road on opposite alternate sides. So here we have angle 6 and angle 3. They're your alternate interior. Now we look at our alternate exterior, 2 words, alternate, opposite sides. If you want to rewrite alternate, that's fine. But now we're looking at outside the 2 lines. This is our exterior. We're checking out outside the road where we're safe from harm's way. So we're looking at angles 1, 5, 4, and 8. We want to follow the exact same thing as alternate, so opposite sides of this transversal. If we start with angle 1, we need to go to the, again, angle 5 and angle 1 are a linear pair. That's one intersection. You need one angle off one intersection, another angle off the other intersection. So we have angle 1, let's cross that street and the transversal to get to angle 8. So 1 and 8 will be a pair of alternate exterior. Then if we look at angle 5 will be alternate exterior with angle 4, crossing the road and that transversal. We have our same side interior, okay? Same side being literally these the words, the same side of that transversal. And then we have between, remember that's our interior. So this one spells it out completely. Same side, inside. So we're going back to looking at the interior here. And we're going back to 2, 6, 3, and 7. But now we want the exact same side of that transversal. We are not going to cross the transversal. So here are 2 of your your same side interior angles. Angle 2 and angle 3. Same side of that transversal. Then we go to the other side of the transversal. We also have angles 6 and 7. 4 of the 5 of these will have 2 pairs, okay, as we've already seen with 3 of them. Now let's take a look at our last one. We are looking at, not our last one, sorry, the next one, same side exterior. So we're on the same side and outside. So again, I've taken my pen and kind of covered up the interior. Again, we want to focus on the same side of that transversal. So here, as we can see, we have same side of the transversal, exterior to that road, we have angles 1 and 4. We shift to the other side of the transversal. We have same side of the transversal, exterior to the road, not getting hit, we have angles 5 and 8. The last one is your corresponding angles. My students will now start realizing why I've been so strong on the word corresponding, meaning matching, okay? We have 2 angles in the corresponding matching positions. We're going to take one angle from one intersection and another one from the other still. What we want to look at is, let's start with angle 1. There will be 4 examples, or 4 pairs on this one, okay? Let's start with angle 1. In this intersection, we want to see that angle 1 is kind of on the top left. So we want to go to the other intersection and find the top left as well. So matching positions, top left, top left. So this will correspond or match with angle 3. Okay, so we looked at angle 1. Let's look at angle 5. Angle 5 on this intersection is the top right. We go to the other intersection and look at the top right, angle 7. All right, so we're done with those. Let's look at angle 2. Angle 2 we're finding is the bottom left. Other intersection, bottom left, we're going to find angle 4. And the last one, the top intersection we haven't talked about, is going to be angle 6. It is on the bottom right. Come over here to the other intersection, bottom right, angle 8. This is all we're focusing on right now, so we're going to go to our last page and we're going to write in what kind of angle pairs they are, and we need to make sure we identify which is the transversal. Notice here we have 4 lines, so we need to focus on which 2 lines do the angles touch, okay, the separate lines, and the transversal will be the shared line. The transversal is always the line they both touch. So let's take a look at the first one here. And I'm going to do a lot of erasing here, okay? Angle 1 and angle 5. So let's go find angle 1 and angle 5. Because we have so many lines, I'm going to suggest that you cover up the line we're not using. What line do both of these angles touch? A, no. B, no. C, yes. They both touch line C. I think I said angle. So T for your transversal is going to be line C. Now we take a look at the positions. Big thing here is we're going to notice that the angles, usually I say, are we on the alternate or same sides of the transversal? We're on the same side. My next question is, are we interior or exterior? And students will go, well, one of each. Ladies and gentlemen, there is no same side, one of each. When you have same side, one interior, one exterior, look, angle 1 is on the top left. Angle 5 is on the top left. They are in matching or corresponding positions. So we have corresponding angles. You're going to see me start abbreviating here, okay? I'm going to erase, and we're going to take a look at angles 4 and 6. 4 and 6. We're going to block off the line that's not involved. And again, say, okay, what line do both of these touch? They both touch line C. So a transversal is C again. Okay, so ask ourselves the first question. Are they on alternate or same sides of this transversal? They are not. They're on alternate. One's to the left, one's to the right. Alternate sides. So I'm going to abbreviate this as ALT, alternate. And are they interior to the road? And draw my car. Are they going to be interior to the road, or are they going to be exterior? They are in the road. So alternate sides of the transversal, interior. And this is how we'll abbreviate for right now. I'm going to put in parentheses AIA, alternate interior angles. So whichever way you would like to abbreviate it, make sure you know that this is alternate interior. All right, we're going to go kind of quick here so we can get through everything and not make this video too long. 4 and 10. So here's angle 4 and here's angle 10. Block out or cover up what lines not be involved, okay? So here we're looking at what line do both of these touch? It's going to be line A. That is our transversal, okay? So we're going differently on the road here. So here's our car. On alternate or in, guys, if you want to rotate your page, please rotate your page, okay? We are on alternate opposite sides of the transversal. So we have alternate. Here's the road. We are exterior to the road. Alternate sides of transversal, exterior to the road. So we have alternate, exterior angles. And there's your one abbreviation, or AEA. All right, next we're going to look at angles 2 and 9. Here's 2 and here's 9. Okay, we're not using line B. So what line are they both sharing? Line A right here. So they're both touching line A. That is our transversal. And we are going to look at, on that transversal, we are on the same side. Again, if you want to rotate, we're on the same side and we're interior. Same side, interior angles. Write out same side, INT, and the abbreviation is SSIA. Next, we're going to look at 4 and 12. 4 and 12, okay? We're not using line B. They're both touching and sharing line A as our transversal. And we look at, again, if you want to, rotate, we're on the same side, interior, exterior. Ooh, one is interior, one is exterior. There is no same side, interior and exterior. 12, looking at it this way, is on the bottom right. 4 is on the bottom right. They are in matching, corresponding positions. We can just do CORR angles. 3 and 9. Here's 3, here's 9. Ignore the line we're not using. They are both going to touch line A, so that is our transversal. And I'm going to show you from this. Without rotating, we're noticing that our transversal, line A, we are on alternate opposite sides, so we have alternate. And they are both interior to that road. That car is going to hit them, so we are interior. And again, we can write AIA. 2 and 7. Angle 2 and angle 7. Going to, not using line D. The line that they both touch is right here. Transversal is line C. 2 and 7 are on alternate sides of that line C, the transversal. So we have alternate. And they are not inside the road. They are exterior to that road. In the next section of notes, I will be using the AEA, AIA, SSIA, and stuff like that, okay? All right, we're almost done, guys. Angle 3 and 12. 3, 12. We're not using line B, so they're both sharing or touching line A. That will be our transversal. We're taking a look. They're on line A, the transversal. They're on the same side. I'll just put SS. And they are interior. They are in the road. So we have same side interior angles. Last one, 1 and 7. They are sharing, both touching line C, which is our transversal. They are on the same side of the transversal. Both of them are to the left, and they are exterior to the road. So we have same side. You probably already think what the abbreviation is going to be. Same side exterior angles, SSEA. Okay, we need to understand these so that we can move on to the next section of notes when we're actually looking at parallel lines. Please search other videos or ask your teacher if you have any questions.